Hey everybody, Mrs. Ekholm and myself will be going back and forth on who's doing videos for one section or another. So you'll be seeing either one of us for each one of these, and this is my first one for the new school year. So bear with me. Might be a little rusty after the summer. Today we're going to be talking about distance. So we're going to start looking at a number line. What I want to focus on here, because this is going to come up when we talk about the formula we're going to look at, when we need to find CF, we're looking for the distance between those 2 points. So we're looking at the distance between C and F on the number line. Now I know you can count the number of spots between, but just so that we're on the same page here as we're going to look forward at what we're actually going to be using this stuff for today, we know there's 6 spots. Okay, there are 6 jumps in between there. Using the number line to count spaces, the distance between C and F is 6. Now, how do we get that? If you don't count, we can look at it this way. If I take my new point, because if we always assume we're going from left to right, okay, if I take my new point of F, I started at C, I walked over to F, how far did I go? 5 was my new spot with F, and I came from C. So if you take your new and subtract your old, you're going to get the distance. So minus and negative is adding. So 5 plus 1 is going to give you 6. So you should end up there with a distance of 6 for CF. Okay, and I understand, like we said just a second ago, that yeah, you can also just count. I know, you were correct. Not going to be able to always count today though. So when we look at AE, again, just for the sake of kind of looking at how we get there, yes, we could count the 7 steps. 1, 2, 3, 4, 5, 6, 7. But again, if I take my new and subtract my old, 3 minus negative 4, okay, minus and negative is adding, I'm going to get 7. So that distance between A and E is 7. That is the length of that segment. It is 7 units long. Okay, so we scroll down here to determine if they are congruent. So you're going to be asked to kind of use this distance idea to kind of prove different things. Congruent, again, means equal or the same. So are those 2 segments, line segment CB and line segment DF, are those 2 segments the same length? Well, let's check out CB first. So CB, okay, again, I won't go through all of it again. We can subtract the new minus the old, or we can just count in this case. That is going to be 2. So CB has a distance of 2. And then when we go to look at DF, we can count that one. That's going to have a distance of 1, 2, 3. So that DF has a distance of 3. And I don't doubt that everybody watching this here right now can easily tell me those 2 are not the same. Okay, so since 2 and 3, or excuse me, CB and DF are not the same distance apart, since those line segments are not the same length, they're not congruent. Now, the answer to that question would just be no. Are they congruent? No. Okay, now, we are not going to just be looking at number lines today. We're going to be taking this into ordered pairs. So when we're looking at a distance formula, okay, we're looking at a distance formula. Let's see if I can get the highlighter to work here. Again, bear with me. Oh, there we go. Nicely done. Okay, that is your distance formula. You're taking notes, write that down. Okay. If you want to replace that JK, okay, for a general formula here, if you want to say D, so distance equals the square root of x squared minus, or excuse me, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, a lot of numbers, a lot of variables, a lot of letters involved here. Please don't be confused. If you're somebody that doesn't love variables, don't worry. Where are these numbers coming from? Well, let's look. our x's are always in the same spot in an ordered pair. They always come first. Your y's always come second, right? So your x2 minus x1, like I was saying over here, when we talked about your new minus your old, this is why I was saying that, okay? Because here, x2 would be your new 2, or excuse me, your new x, your second x. So in this case, it could be either one, okay? And then that y2 minus y1, you're looking at your two y values, the second value in those ordered pairs. The one thing that is important, okay, x2 minus x1, you have to make sure that you are going in that direction. For example, we've got -3, we've got -3 minus 4. So we've got -3 minus 4. Notice how I used this x term first. So that means I have to use that same y term first when I go to subtract. So -7 minus 3. Okay? So once I've got those two things done, shouldn't say done, but once I've got those two things set up, we're just following the order of operations, okay? You're going to subtract, you're going to square, take the square root, you're done. All right? So when I've got my x2 minus x1, my -3 minus 4, that gives me -7. -3 minus 7 gives me -10. I square those two. Now, remember, when you square a negative number, it turns positive. Multiplying a negative by a negative will turn it positive. So you're going to end up with a positive 49 plus a positive 100. You'll get the square root of 149, which on a calculator, you're going to have is equals 7. Okay? So we end up with the distance of 7. Now, let's actually kind of look at using this here. And here's another example that you can look at the visualizing of it. Just to kind of prove what I was talking about a couple minutes ago, where we're not going to be looking at straight lines, or I should say number lines, at every single point today. Sure, I can count these two distances, right? The 7 and the 10. If I'm looking for that straight distance between those 2 points, J and K, I cannot count diagonally across a coordinate plane. Okay, the only way I can count on a coordinate plane is straight up and down or straight left and right. Once we have any type of distance where anything diagonal is involved, you can't count anymore. Those aren't full units, right? We're talking about cutting across those units. That's where this distance formula is coming in here today. All right, so let's just plot a couple points. This should be review. This should be something that we all know how to do by now. The number one mistake I see is that we get our x's and y's mixed up. X is left and right, y is up and down. This is your x-axis, this is your y-axis. You remember that, you'll be fine. We're going to plot these points, and then we're going to use that formula, okay? So for point C, we've got -4, -6. Right there is point C. And then 5, -1 is going to be point D. 1, 2, 3, 4, 5, and then down 1. That's your point D. Now, two things can happen here. Okay, you can use your formula. Okay, D equals the square root of x2 minus x1 squared. Hold on, keep writing it as squared. I told you guys I was rusty from the summer. I was not lying. Square root of x sub 2 minus x sub 1 squared plus y2 minus y1 squared. You can use your distance formula, or you can do kind of what this example did down here. You can count those units. As long as you are looking or moving straight up or down or straight left or right, you can count. That'll give you the distance. So you can make a right triangle out of here. Okay, so you can make a right triangle. So we're going 1, 2, 3, 4, 5. That is 5 units. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. That length is 9 units. Okay, and those are going to be your two sides. So then you're going to be able to kind of plug those right in somewhere down that distance formula. I'll show you here in a second. So really what these two things are, let me change colors here. Your x2 and your x1, your y2, your y1, you're going to get these same 5 and 9 numbers. So let's watch that once. So let's go through this formula. I'm going to erase this stuff to get a little bit more room. So if I've got d equals the square root of x2 minus x1 squared plus y2 minus y1 squared, let's just start plugging these things in. So that would mean I've got the square root of, oh my goodness, still getting used to this, writing with a stylus here, and it's a little bit of a learning curve sometimes. Square root of, so that x2 minus x1, so x2 is going to be 5 minus -4, and then that will eventually be squared, plus, get my y's here, y2 will be -1, and then minus that -6. A lot of negatives fit into that one. And that's going to be squared. Here's where these two numbers come in, okay? You've got 5 minus -4, which is really like 5 plus 4. That's going to be 9 that we're going to have to square in a second. And then I've got plus -1 minus -6, which again, that's like adding. Minus a negative is addition. -1 plus 6 is 5, and that will be squared in a minute. That is where these two come from. Okay, so if you'd rather count, those are the numbers that you're squaring inside of the square root symbol. So then I've got 9 squared is 81, plus 5 squared, which is 25, and I'm going to end up then with square root of 106. Now that is not a perfect square. I'm pretty sure Alex or our textbook will accept this as a final answer. If that changes, we'll let you guys know in class, or let you know before you get working on that assignment. But if it's not a perfect square, you can't simplify that any further, that should be fine for a final answer. Again, I will let you know, or Mrs. Ekholm will let you know if that's not going to be the case. Last thing I just want to mention here for a sec, that's really all you're going to be doing today. Just to look at this, just another example as to why this distance formula is going to come in handy. You are not going to be able to count much for distance when you have decimals. So we can graph these just fine. I've got a point here at 212.0 and 151.6. So about 212 will be right here, 151.6 will be right about there. And then I've got 435.3 and 311.3. Whoa, not mean to be moving the camera around. 435.3 somewhere about here, and 311.3 somewhere like there-ish maybe. You can see I'm probably not going to be able to count that. Okay, this is where you're going to have to be using that distance formula. So make sure that you are plugging into this distance formula. Whoa. Make sure you're plugging into this distance formula, especially if you're unable to count. If you are able to count that distance like we were here, that's great. You're still going to have to make sure you're using those last couple steps of the distance formula anyway. Okay, so that's all we've got for today's video. If you've got any questions, let myself or Mrs. Ekholm know, depending on whose class you're in, and we'll go from there. So, first video for myself. I feel like I knocked some rust off. I hope you stuck around for the whole thing. Got a little lengthy, made a couple mistakes, but we'll be just fine. We'll be improving every day. So, thank you. Hope this helped, and we'll see you guys later.